Welcome back to my channel. Today I'm going to show you how we can simulate water rise along a river bank. We are again in our location in Republic of Congo in Betu, where we have a refugee site, we have the village of Betu, and we have a big river. We want to see what would happen if we increase the water of this river, which part of the city or which part of the area is going to be flooded or not. We have the Google imagery as a background, and we have the digital terrain model FabDEM. The digital terrain model FabDEM is a huge file, therefore we need to crop it. To crop it, just zoom in on the area of interest, go to Raster, Extraction, crop raster layer by extent. You choose the digital terrain model. You select the extent by canvas extent in this case, and we save the new file with the name FabDEM cropped, and we run it. So we don't need anymore the original FabDEM. At this point, we need to reproject our cropped digital terrain model from geographic coordinate into UTM metric coordinate. You type warp on the processing toolbox, you choose the source coordinate geographic, you select the target coordinates UTM 34 north, and we save the file with the name FabDEM cropped UTM, and we run it. So we can also deactivate the original FabDEM cropped. At this point, we can create contour line. So we go to Raster, Extraction, Contour. We choose the FabDEM cropped UTM. We put 0.1. We know this area is extremely flat. And we can save the generated file as contour 10 centimeter. This helps you to understand a little bit how the situation looks like, how steep is the area, and we run it. So you can see that on the water there are no contour line. This means that the FabDEM consider the river extremely flat. In reality, also the river would have a small slope. In other cases, you might have contour line going across the river as well. If you check the elevation of the river, you see that it is 323.5 meter everywhere. And as soon as you go out of the river, so the black area, the elevation increase. FabDEM consider the river as completely flat, which is not the case in reality. In reality, also the river water surface has a gentle slope going downwards. Now we can create a new shapefile polygon that cover the river area. So we go to create, and I call this polygon a river polygon. This is a polygon, and it has the UTM 34 north projection. Here it is. And I can start to draw the river within the area of interest. You have to be very carefully and not to draw over the river, so only on the black area. You do not need to be extremely precise, just stay on the river elevation. Here it is. I have now my river polygon developed. I save it. I change just the color. I do it blue and a little bit transparent. Here it is. At this point, I want to convert this river polygon to a line. To do that, I go to Vector, I go to Geometry tool, and I click on Polygon to Line. I save the new created shapefile as river bank, and I run. Here it is. Now I have just the lines and no more a polygon. At this point I have to create regular points along the river bank. To do that, I look for the processing toolbox for the command points along geometry. I choose the river bank as input layer. The distance between points I take 10 meters. If I take a shorter distance, the computer time will definitely increase a lot. And I call the new shapefile as point along bank. Here it is. I have the point every 10 meters. Let's verify that it is 10 meter. Yes, it is 10 meter. At this point I want to give the elevation to each point based on the digital terrain model. To do that, I look in the processing toolbox for the command called sample raster values. I choose the input layer. I choose the raster layer, FabDEM. I give the name of the column that I want to create. I call it eleve. And I save this new shapefile as point along bank elevation. Now let's check what I have inside. Here you can see that I have the points, and each point's got an elevation, and all the elevation is actually 323.5 meter, because like I was saying, the digital elevation model consider this river totally flat. In order to assure that I did a proper job, I have to identify those points that have a strange elevation. You can see I have somewhere points with different elevation. Let's see where those points are and why do they have a different elevation. Those points have a different elevation. Let's see where they are. Yes, they are on a small sandbank. So what I can do, either I redo all this process, or I just delete those points. I delete those points. Also I deleted those one. Voila, that's it. Let's cross check again all the elevation. Those also are not good. There is also a small sandbank there. I delete those points as well. It is important that you really only have the points on the water level and not on a sandbank or on a bank. Let's cross check again. It seems that now all the points are on the right location. At this point I have to create to each point along the river bank a buffer. To do that, I go to Vector, Geoprocessing Tool, Buffer. I choose the right input layer. I write the distance between of the buffer, 4 meters for example, and I put 15 as a segment in order to have a better buffer. I save the file as buffer along bank and I run. Here it is. We can see we have our buffers and we have the point between. It is interesting to see when you open the attribute of the buffers that each buffer always has also the elevation. The next important step is to create within the buffer along bank shapefile new attributes with new elevation. We should increase each point of, for example, 1 meter, then 2 meter, then 3 meter, 4 meter, and give to this point the new elevation. To do that, simple, open the attribute table, click on the field calculator, type field name elevation +1, select within the option fields and value, and click twice on the elevation field, and additionally type +1. Be sure or be careful to have the right output file type. It must be decimal number real. In that case, a precision of 3 is more than enough. So you do that for 2 meters, 3 meter, 4 meter, 5 meters and 6 meter, and this will create additional column with additional elevation. So we are going to simulate the water level rise every meter up to 7 meters. You can see here we have the same shapefile and we have added 7 columns with new elevations.